Now we have another method, which is making rounded edges with Rhinoceros 7. So if you don't have or you don't like to use 3D code, this is the best alternative method for automatic smoothing out sharp edges. So Quad Remesh is a new feature in Rhino 7, which is currently in work in progress stage, and it lets you create a quad mesh from mesh or NURBS geometry. In jewelry, we can use it to soften hard to fillet areas for rendering, and also to optimize topology and symmetry of scanned data or triangulated meshes. So having quads in your mesh results in a much smoother 3D model, and it also makes it easier to edit if needed. Having a nice smooth 3D models makes the reflections look beautiful. Quad Remesh command uses a unique algorithm to quadrangulate 3D meshes with an optimized polygon layout. It can be used to create a mesh fully composed of quads from surfaces, polysurfaces, meshes, and sub-Ds. In this image, we have 4 rings. On the far left, we have a regular polysurface that we create in Matrix or Rhino. And the second one is a regular mesh that we get with mesh command. When we mesh these NURBS surfaces, you can see how it gets a bit messy. We have some quads, some triangles, some are even positioned badly. Like I explained in the 3D code method, you want to have as many quads as possible over triangles and aim to get a nice topology. This is where Quad Remesh is coming in. The third ring is still a mesh, but with a nice topology and all quads made with Quad Remesh command. Pretty much it looks exactly like the ring after the autopo step in 3D code method, but this method is actually not failing that often. So this is already a pretty great result, and I might say this method is producing the best results in most cases. Not to mention it is very fast and easy. The last ring on the far right is actually something pretty amazing. Sub-D is a new way of modeling inside Rhino 7. It is short for subdivision modeling, basically what once T-splines was and what ClayU is now. But since it's built in Rhino, it is already a very powerful tool, and I'm pretty sure when Rhino 7 gets incorporated in Matrix Gold, it will be the best feature since T-splines. And definitely it's gonna be much better than ClayU. In this image, you can clearly see how everything is much more smoother and rounded than it is on Quad Remesh mesh. And also, since it is subdivision, it is also editable. Manipulating this subdivision is much easier than manipulating and editing mesh. So what are the pros and cons of this method? So for the pros, we have this method as really fast and easy to use, and it gives you a great quality. So I'm pretty sure you're going to be using this method the most. And as for the cons, well, occasionally surface imperfections. Sometimes it can fail and sometimes it can give you some open meshes. So it's still not perfect, but I think it's the best method for rounding the edges. So let me show it to you how it's done in Rhino 7. I have a sample ring here, which I use for the 3D code method as well. And as mentioned before, it does have some edges rounded, but some are still very sharp. And we're going to use Quad Remesh to make all the edges rounded. But before that, I just want to make a mesh out of these NURBS so we can compare. I'm going to use my default mesh settings and move the mesh away from my ring. Now you can see this mesh is pretty messy. It does have some quads over here that we like, but it also has plenty of triangles, which we are trying to get rid of. And with quad remesh, we're gonna end up only with quads. And also sometimes quad remesh is not going to work on your NURBS for any reason. And in that case, it's good to convert these NURBS to the classic mesh, and that will increase your chances because you can use quad remesh on meshes as well. So let's go ahead and start the quad remesh command. I'm not going to go through every setting here in depth, but I will explain the important ones. So first we got target quad count, which is the most important. And it really depends on the complexity of your model. Sometimes you need to increase it, sometimes you need to decrease the number of the quad count. You just have to try it out for each of your models and find out the sweet spot. Right now I have it set to 2000 quads. And the next setting is use surface edges. So we need to set this to off as we don't want it to use any surface edges as guides. We want it to make a nice topology, and when following NURBS edges, it can also make a mess out of quads. If you have a ring that has symmetry, like ours does here, you can turn on the axis symmetry options to speed up calculation and retopology. So I have turned on the X and Y axis because these are the axes that this ring is symmetric along. And the final important option here is detect hard edges. This is another setting that we need to turn off as we don't want any edges to stay sharp. We want all the edges to be rounded. And before we go on, just make sure you have adaptive quad count turned on, as it will help optimize topology of your quads. So let's go ahead and click OK and see what we got. So straight away, you can see that the quad remesh is working, and it did a pretty good job at topology. You can see that the quads are pretty much equal and positioned nicely. But also you can see that we are getting some straight surfaces where we would like them to be rounded. And if we turn on the rendered view, we can clearly see how that affects our model, and it shows some surface artifacts. So obviously, we need to increase the target quad count. So let's go ahead and do that. Start the quad remesh command. And this time we will increase the number to 20,000. Now, this is much better, but we are still getting some artifacts around some joints. But these are much less than on the previous one. So in some cases, this is going to be okay. And if you compare this to the 3D code method, this is even better because we have only 20,000 quads instead of 100K like in 3D code. So of course, we could have lowered it down in 3D code as well, but over here, it's much faster to cycle through multiple iterations and try out different settings. If you remember, in 3D code method, these things are pretty slow. So even though we are pretty happy with the results here, we can do it even better. So first of all, let's try and lower the target quad count and see what happens. We will set it to 8,000 this time, but also we will convert it to subdivision. Now we see that we got a lot smoother results with using subdivision. And if you compare this part, for instance, you can see that on this rounded edge, we have 3 or even more straight lines, which are actually causing the surface artifacts. But on the subdivision, we have it nice and round. And if we turn on the rendered view, we can see that we no longer have any artifacts like on the previous ones, and we have all our edges nice and smooth. Now, the only problem is you can't import subdivision into Keyshot, at least not yet. So the workaround for this is to convert this subdivision back to NURBS. And we're going to use the to NURBS command to convert the subdivision to NURBS. So we are getting a warning window here that is telling us that it's going to create over 20,000 NURBS surfaces. Well, this is because each quad is going to be one surface. And in some cases, depending on your computer, this can take quite a while. And as it says here, your computer might run out of memory and crash. But since I have 32 gigs of RAM and I did this ring previously, I do know that I have enough memory and it will not crash. If you are suspecting that it might crash, then it's good for you to try some lower quad target number and see if you can get better results like that. So right now you have an option to save or just continue without saving, which we'll do. We will see how long this operation will take. And once you get your new NURBS, you can save it as a 3M file and import it into Keyshot with no problems. Just make sure you save it as Rhino 6 file, not Rhino 7 file.